Hey everyone, Mr. Voikin here, and we're going to take a look at Unit 5, Lesson 2. The pages are 275 to 277 for all the instructions, and following that there will be the assignment. Okay, so last day we went through what polynomials are. We broke them down into their separate parts. Determine what the difference is between a numerical coefficient and a constant, or the difference between an algebraic expression and an equation. We looked at monomials versus binomials and trinomials, and finally we looked at the degree of monomials and the degree of polynomials. So you need to make sure that you are familiar with that, as well as descending and ascending order based on the degree of the variable. So if you are familiar with all that, it's going to make that base that you'll have is going to make learning and understanding the subsequent units a lot easier. Okay, so let's take a look at what we have here. It says use the distributive law. Now, back in Canada, we used to just have a saying for this, which was feed the chickens. Sort of a funny thing to say, but that is basically this one right here, the distributive property. So we're going to take this algebraic expression, which is 4 times 3x plus 1, and we're going to expand it out. Okay, so we're going to basically multiply 4 times that binomial. Okay, so by feeding the chickens, it sort of went like this. We said this is the farmer right here, and he needs to go into the coop. And this is the coop right here, and he needs to feed that chicken, but he also needs to feed that chicken. And basically what are we doing here? We are multiplying through. So this becomes 4 times 3x. Well, 4 times 3x becomes 12x. Now we're going to do 4 times positive 1, which is 4. So that one expanded out becomes 12x plus 4. Now what we want to do is make sure that that is in descending order, and that all anything that are similar, we gather those like terms. So x has a degree of 1, and the constant 4 has a degree of 0, so it is in descending order. Everything's good. Let's take a look at the second one, which is negative 5 times 2x squared plus x minus 6. So now we're going to be multiplying that constant of 5, that's the farmer, and this time I guess this farmer has a bigger coop because he can afford to have 3 chickens. That's 1 chicken, 2 chickens, and 3 chickens. So the farmer needs to go feed those chickens, and we need to expand this out, and again make sure that all like terms are collected and gathered together, and then it's put in descending order. So don't forget this little negative sign there. This is negative 5 times 2x squared. So negative 5 times 2 is negative 10, and don't forget the x squared. Now negative 5 times x is, now don't forget in front of that x there is an imaginary little 1, and that becomes negative 5x. And finally we have negative 5 times negative 6. 2 negatives make a positive, so we have a positive 30. Then we want to double check, make sure there's no like terms. So I've got squareds right here. That's my first term, negative 10x squared. My second term is negative 5x, and the final term, which is a constant, because there's no variable right there, that is going to be 30. Now don't forget that in here we have one variable. That variable is x. We have a degree of 2 on the first, 1 on the second, and 0 on the third. we've got a numerical coefficient in the first term of -10 and a numerical coefficient of -5 in the second term. And it is definitely in descending order, so everything looks good. Okay, we'll take a look at C, and they have x cubed minus 2 times x squared. Okay, so I'll just write this down really quickly. So it's x cubed minus 2, that's inside the coop, and the farmer is the x squared right there. And now we just need to expand this out following the same process. So the farmer is going to feed that one and that one right there. Okay, now basically we're going to look at what is x squared times x cubed. Well, we need to remember the rules of multiplying with exponents. And when we're multiplying, in this case, x squared times x cubed, that is going to equal x to the 2 plus 3, which equals x5. Okay, that first one is done. Now the second one, x squared times -2, and that is just going to equal -2x squared. So we have, again, two terms right here, and this first one has a degree of 5 and the second one has a degree of 2. So to put this in descending order, the answer would be x5 minus 2x squared. Okay, and I think there's one more. Sorry, that went really fast. Where was I? Right here. Okay, so I've got a -3x as our farmer, and I got 3 different terms inside the coop. So this time we're doing -3x times 7x minus 2y plus z. So here I've got 3 different variables. I'm just going to add another page in here really quickly. Add that below current template. Okay, and I'm just going to take this and move it down below because there's no room here. So we're going to cut that out and we'll place it right here. Okay, so what are we going to do in this case? Well, same thing, you guys. We got one farmer, feed that chicken, and feed that chicken. For some of you that are constantly making mistakes with the positives and negatives, it might be a good idea just to sort of circle that term. It includes the sign that's in front of it. And that one right there. So those are our 3 chickens that we're multiplying together. And my farmer is out here, again, including the sign in front. So the first one is -3x times 7x. The second one is -3x times -2y. The third one is -3x times z. Make sure you put a line through your z so it doesn't look like a 2. Easy to make a mistake. So -3 times 7 is -21, and I have an x to the power of 1 and x to the power of 1, so I end up with an x to the power of 2. On the second one, we got -3 times -2, which is +6, and I've got an x times a y, so that just becomes an xy. And the third one has a -3 times the imaginary 1 that's in front there, so it just becomes -3, and x times z becomes xz. So now when we're looking at the degree, in order to put this in descending order, notice that each one of them has the variable x in it. Okay, so if it was me, I'd be using this one first because it has a degree of 2, but both of these have a degree of 1, so which one are we going to use first? Well, to me, I would choose this one second because y comes before z. So for me, my answer would be -21x squared plus 6xy minus 3xz. Okay, here we just have basically the same thing, except there's a little bit more complexity to it. So let's start with the first one, which says 6 minus 4 times 8x plus 1. So this is multiplication, and then we have a subtraction right here, and they're sort of separate. So I need to deal with the multiplication one first, because I'm just following the rules of BEDMAS. And multiplication comes before the subtraction. So what are we going to do? Well, just feed the chickens and expand this out. So the 6 is still going to stay there, and it's going to be minus. Minus what? Well, what is 4 times 8? It's 32, and don't forget the x. What is 4 times 1? It's plus 4. And what you need to do, we're subtracting this whole thing. So we're subtracting all of that. So I need to put that in brackets. And now we're going to go back to the last unit where we have to say, hey, I see that we've got a negative sign right here, which means I need to subtract everything in here. So this needs to change to a positive, this to a negative, and this one needs to change to a negative. So I'm just going to rewrite this out as 6 plus negative 32x minus 4. Now it makes it real. Why do I have two x's there? That should be a 32. X minus 4. Okay, so now it makes it really simple. So 6 and 4, those are constants. I've got this one right here with a degree of 1. All I need to do is gather the like terms. Okay. If you want to, we could even get rid of the brackets at this point, and it'd be like 6 positive and negative together becomes minus 32x minus 4. Having trouble with that one. Okay, so when I simplify everything and gather my like terms, I want to take a look. Well, I've got a 6 and I've got a negative 4. 6 and a negative 4 together become 2. And I have a negative 32x, which has a degree of 1, and the constant has a degree of 0, so it's going to go first as negative 32x plus 2, and that is our final answer for that one. Okay, let's take a look at the second one, which is going to be 4 times 2x minus 3 minus 2 times x. What's going on? X minus 6. Okay, so, well, what are we going to do here? We're going to go expand this one, expand that one, and then we're going to subtract those two. So it's a good idea to keep those brackets around those separate terms that we sort of have here. Okay, so let's expand the first one right here. So I got 4 times 2x, and that's going to become 8x. And then I have 4 times negative 3, which is going to become negative 12. And like I said, let's keep that in brackets and subtract whatever I calculate or expand out here. So what is 2 times x? Well, that becomes 2x. And what is 2 times negative 6? That's negative 12. Again, take a look. We have a negative in between. I'm subtracting these two, so I'm going to rewrite this. I'm going to change this to a positive and change the signs of each of those terms within that second binomial right there. Okay, so if I rewrite this out, what do I have? I've got 8x minus 12 plus negative 2x plus 12. These two signs being side by side here, a positive and negative together, can just turn into a negative. Okay, so now what I have, I'm going to take a look. I've got this term, which is an 8x, and I've got a negative 2x. And if I look at my constants, I have a negative 12 and a positive 12. So now we're just going to put those together. 8x and negative 2x becomes 6x, negative 12 and positive 12. Those are just going to cancel each other right out. So I have basically plus 0, but I would never write that. So the final answer is just going to be 6x. Okay, and let's take a look at C. So exact same thing. The only thing that's really different is it's just getting a little bit longer. So now instead of multiplying by a constant by a binomial, I've got this term which is 5x, and I'm multiplying it by a trinomial. So what do we have? 5x times 3x squared minus 7x plus 1. I'm going to subtract 4x plus 3x squared. Now notice on the second one there's nothing on the outside of those brackets to multiply by, so there's nothing there and there's sort of nothing there. So I only really need to expand that one and then follow the other rules to start gathering like terms. Okay, so I've got 3 chickens to feed right there. 1, 2, and tray. So what is 5x times 3x squared? That's going to be 15x cubed. I got 5 times negative 7, which is minus 35, and I got an x times an x in that one, which becomes x squared. And now I have a 5x times 1, which is plus 5x. Okay, now again, keep that in brackets. We're going to be subtracting this other expression right here. So what are we doing when we're subtracting? We're going to change the signs of everything. Okay, so just to visualize this for you, I'm going to rewrite it. So I got 15x cubed minus 35x squared plus 5x plus negative 4x minus 3x squared. These two here will go together to equal, to be a negative sign. And so now it's a good idea to, take a pen and just sort of circle everything that's like. So I got cubed. Do I have any more cubes? No. I got a square. Don't forget to include the sign that's in front, and I have a square right there. Do I have any more squares? No. Okay, I've got an x, so something with a degree of 1, and I've got this one right there. Do I have anything else? No. Now we just need to gather the like terms, starting with the term that has the highest degree, which is a degree of 3. On that, this has a degree of 2 and a degree of 1, a degree of 1 and a degree of 2. So 15x cubed stands alone. I have negative 35x squared and negative 3x squared, and that turns out to be negative 38x squared, and those ones are done as well. And now I've got positive 5x and negative 4x, leaving me with positive 1x, and those ones are done. Okay, and the last thing we need to learn for this unit before we move on to the assignment is to follow these sort of word problems, and we got a little bit of measurement to do here. So we're calculating the area of this shape. So it's a complex shape made up of 2 rectangles, and the first one says let's add the 2 together. So essentially we could split this up into 2 rectangles by drawing a line straight across there like that. Okay, so you can see that the top rectangle is going to figure out the area. Remember, area is length times width. It's going to be that dimension times that dimension. And on the bottom rectangle, it's going to be that dimension times that dimension, which we don't have. But notice that on the right-hand side, it says 4x. And up here, it's a 2x. So 2x plus 2x on this side is going to give us our 4x that's on the other side. Okay, so now it basically says that we need to add these two rectangles together. So we've already done that, so we're just going to do it again. So essentially what we have is, for the top triangle here that we'll call triangle 1, we have 2x times 3x plus 2. For the bottom triangle, rectangle, we're going to add 2x times x plus 5. Now, what I'm essentially doing is adding that to that right there. Now, because it's an addition, I'm not going to have to change any of the signs, so it's a lot simpler in this case. But I still do need to feed those chickens there and feed those chickens there. So we're going to start off with 2x times 3x, which is going to be 6x squared. 2x times 2 is positive 4x. On the other one, I'm going to be adding to that, so I can keep that in brackets if I want to, 2x times x, which is going to be 2x squared, and 2x times positive 5 is going to be positive 10x. Okay, now what I need to do, because it's addition here, like I said, I don't need to change any of the signs. I just need to gather all my like terms. So I'm just going to get rid of these little brackets that are right here. And again, use some color to sort of identify what I have. So I've got a degree of 2, another degree of 2, and I got a degree of 1, another degree of 1. Now let's just gather those like terms. So 6x squareds and 2x squareds become 8x squareds. Done and done. 10x plus 4x is going to be 14x, and you guys are done as well. Final answer. Okay, now on the second one, we're basically going to be subtracting them. So sort of, how would you do that? Well, I guess we could essentially pretend that, you know, there was like another sort of portion right here, and I would take the area of the whole thing that's sort of going around here like this, and from that I'm going to subtract this little part in here, and that will give me what's left there. Okay, so I need to find the area of the whole thing first. So let's see what dimensions they give us and what we can pull out of here. Well, the whole thing would be that measurement times that measurement, the total sort of height or width that we have and the total length right there. So I can just lay that one out right now. Okay, so what do we have? I'm going to multiply 4x. I'm going to put the 4x on the outside of the bracket, just makes more sense, times 3x plus 2. So that's the large one, and from that we're going to subtract the smaller one. So this is the large rectangle. From that we're going to subtract the small rectangle. So what is the dimensions of this sort of small rectangle right here that we're going to be subtracting? Well, again, we already calculated this in the other one. This one right here is going to be 2x. Now the other one right here isn't as easy. So basically we're going to be taking this long dimension right here, and we're going to be subtracting that dimension, which would leave us with that right there. So what do I need to solve this? That I'll just sort of call my SL for short length or something like that. Okay, so I'm going to have to do a little bit of math on the side here. So it's going to be 3x, the long one minus the short one, right? So the long one minus the short one. So it's going to be 3x plus 2 minus the x plus 5. And remember, that's going to be, we're subtracting the whole thing. Whoa, there's that negative sign again. Change it to a positive and change everything else. So let's just rewrite this really quickly. It says 3x plus 2 plus negative x minus 5. These two signs that are in there are going to turn into a negative. So now I just need to gather my like terms. I've got 3 x's, I've got a negative x, I've got a positive 2, and I have a negative 5. Once I gather those like terms down here, we're going to have 3x minus x is going to be 2x, and I've got a 2 and a negative 5, which is negative 3. So essentially what has happened is this part right here has become a 2x minus 3. So this has become 2x minus 3. So now what I need to do is multiply that times that to get this and then subtract it. That's my small one. So it's 2x minus 3 times 2x. So 2x times 2x minus 3. And now basically I just need to recognize right away there's a negative sign there. So I'm going to segregate these ones here. I'm going to do the math. 4x times 3x is 12x squared. 4x times 2 is 8x. I'm going to subtract from that the expansion of this one inside these large brackets. 2x times 2x becomes 4x squared. 2x times negative 3 becomes negative 6x. Don't forget we're going to put that in brackets, which basically means we're going to change the sign of everything. So this first one really is just going to stay as negative, and the second one is going to change to a positive. And now I don't really need those brackets anymore, and I'm just going to gather my like terms. So I've got a degree of 2 right there, and another degree of 2, grab its sign. I've got a degree of 1, and I got a degree of 1. Now what I need to do is just solve this. So 12x squared minus 4x squared is going to be 8x squared, and I have an 8x plus a 6x, which is plus 14x. And you can see in both cases we ended up with the same thing, there and there. The bottom one is using subtraction and the top one is using addition. All right, everyone, now that I've finished that lesson, I have a small assignment for you to do at home and bring back completed, showing all your work neatly written out, the answer to these 3 questions. Okay, we'll see you in class and we'll continue on with the assignment that is on page 279 all the way to 282.